Hi students, here is the practice part of electric field under the fast track revision series for JEE Main. This electric field part we have divided in three parts for the problem discussion. First is based on the questions involving the basics of the electric field like the formula F equal to QE only. Second, the problems based on discrete point charges, electric field due to discrete point charges, and third due to the continuous charges. So let's continue with the first question. A very simple question is given. A charged particle of 2 coulomb is experiencing an electric force of 2000 Newton towards east. Say this is east. Charge is given, which is given as plus 2 coulomb, and it is experiencing an electric force of 2000 Newton. Electric force of, 200 Newton. Now we know the formula F is equal to QE. So they are asking determine the electric field at point A. So electric field will be equal to F by Q. So it will be force is 200, charge is 2, so it is 100 Newton. Since we are using the vector equation, charge has to be substituted with sign and the electric field direction will be along the east. So your answer will be very simple question only on the basis of the formula F equal to QE vector. Force experienced by a charged particle placed at the electric field is QE. Next, come to the next one. Calculate the electric field intensity which would be just sufficient to balance the weight of a particle of charge minus 10. Now a charged particle is there, charged particle of charge minus 10 microcoulomb, and its mass is given as 10 milligram. Now it is going to experience two forces. One is the mg force. So we need, it has to be balanced. So we need the electric field in which way, so that the electric force will be upward. So electric force has to be upward. Since it is a negative charge, if we write the electric force as equal to Q into E vector, since Q is negative, the direction of electric force and electric field will be opposite to each other. So it means this particular thing is possible if we keep the electric field in the downward direction. If the electric field is in the downward direction, then it can be balanced. And in that way, we have mg is equal to QE. Now here I am not writing the uh, sign vector equation, directly equating. M is given as 10 milligram, so 10 into 10 power minus 6. For simplicity, the value of G taken 10 is equal to 10 microcoulomb, so 10 into 10 minus 6 into E. So the electric field will come out to be 10 volt meter or Newton per coulomb. You can write it. 10 Newton per coulomb direction, vertical downward direction. So here with the help of these two questions, we are trying to explain that force equal to QE vector, electric force experienced by a charged particle in an electric field E vector, is given by F vector equal to Q into E vector. Q has to be substituted with sign. Let's take the another question. Electrostatic force experienced by a charged particle. What is the value of the charged particle given? Minus 3 microcoulomb. Placed at point P due to a point charge system S. There is one, okay, here diagram is given. This is some charge system is given to you, this one. Due to this charge system, we are having the electric force experienced by this particle here is going to be this one, F equal to 21. So the force is going to be equal to QE vector. So force given is 21 I cap plus 9 j cap. and this is equal to, charge is given as -3 microcoulomb, so -3 into 10 power -6 into E vector. So from here we got the E vector as -7 I cap plus 3 j cap into 10 power 6 Newton per coulomb. Now they are saying find out the electric field intensity at point due to S. This is the first part, we got the answer. This is the answer for the first part. Now they are saying if now 2 microcoulomb charge is placed and -3 microcoulomb is removed. Means from here -3 microcoulomb taken and 2 microcoulomb has been brought. Then what is the force experienced by it? Now for that, the force experienced by the 2 microcoulomb charge is equal to Q into E vector. Now Q is 2 microcoulomb. So 2 into 10 power -6 into -7 I cap plus 3 j cap -3 j cap into 10 power 6 Newton. And when you multiply, this cancelled and it will become -14 I cap minus 6 j cap Newton. Now here also the same concept but has been presented in different way. First, the force given by one charge particle, negative charge particle. Then you determine electric field at that location. Then they ask what is the force experienced by other charge particle. And then it has been computed again by using F equal to QE. Now up to here, questions were based directly on the formula. But how the same situation can be used in other using some other concept also, those few questions are there. The bob of a simple pendulum has a mass of 2 gram and a charge of 5 microcoulomb. When bob is there of a simple pendulum, it is having the mass and charge Q. Mass given as 2 gram and charge 5 microcoulomb. If it is at rest in a uniform horizontal electric field of intensity 2000 volt per meter, means if external field is there here, magnitude 2000, and particle is at rest, then at equilibrium the angle that the pendulum makes with the vertical. What is happening? This charge particle experience the force QE here, and the string will take the shape now this way. And in this situation then, they are asking what is the angle made by the string with the vertical. This angle theta they are asking. Now here the forces are, one is mg, one is electric force QE. Since the charge is positive, electric force is in the direction of electric field, and tension T. Now since the object is in equilibrium, net force is 0. Resolve the forces along the horizontal and vertical. So T cos theta will be equal to, T cos theta is equal to mg, and T sin theta will be equal to QE. So divide the expression, you will have tan theta is equal to QE by mg. Now substitute the value of QE and mg etc. Q is 5 microcoulomb, so 5 into 10 power -6. E is 2000. M is 2 gram, so 2 into 10 power -3. Mg is 10. This over 5 to 10 cancel, 1 upon 2. So theta is equal to 10 inverse 0.5. Your answer will be then option 2. Now again, only the concept of Newton's laws of motion, equilibrium has been involved more. Otherwise, the concept from the electrostatics is only F equal to QE. Take next question. This question number 4 was from previous year JEE Main. Now we'll take the fifth question. This fifth question is also from previous year AIEEE, but it is like before 2019. Now take this question. The bob of a simple pendulum has a mass of 40 gram and a positive charge of this. Means same thing is given. Mass given. Mass of the bob given. 40 gram. Charge of the bob given. 4 microcoulomb. Now it makes 20 oscillations in 45 seconds. Now we know what is the formula for the time period. For the time period, we have the formula 2 pi under root L by G. It is making 20 oscillation in 45 seconds. So in 45 seconds, 20 oscillations. So this will be the time period. Now they are saying a vertical electric field is pointing. So a vertical electric field will start of magnitude, and the magnitude of the electric field is also given 2.5 into 10 to the power 4 Newton per coulomb. Is switched on. Now they are saying how much time will it now take to complete the 20 oscillation, or we can say because of the switching on this electric field, what is the change on the time period we have to find, something like that. So here what happens now, the force acting, one is mg, one is tension. So in the SHM we have seen it is going to perform the oscillation with the time period this when only the gravity force is providing the restoring torque. But now here what happens, one QE will also act. So the net force in the downward direction we can say is mg effective is equal to mg minus QE. So we can say the new time period is going to be equal to 2 pi under root L upon G effective, and G effective will become G minus QE by M. Now if you are using this particular thing, now divide the expression and you have to find the time period for 20 oscillation. So multiply it by 20. So 20 t dash you have to find. This is what we have to find. Divide these two expression, this expression and this expression you divide. Now you will get under root G minus QE by M upon G is equal to 45 upon T dash. So get the value of T dash and multiply it with 20. And required answer will be T dash into 20. You can do this calculation then. Okay. This way we can solve this. Now here also you see there's nothing very critical, only you must know what is the G effective under some cases. The similar type of question has been asked in JEE Main when the pendulum is in the horizontal accelerating car. Then the G effective will in that case will be under root G square plus uh, M G square plus A square under root. So those type of questions are there. Now let's come to the next question. Suppose a uniformly charged wall provides a uniform electric field of this much amount. Some value is given. This is a charged wall, and this is providing a uniform electric field of 2 into 10 power 4 Newton per coulomb. A charged particle of mass 2 gram being suspended through a silk thread of length 20 centimeter, means one silk thread is there, and with the help of that one charged particle has been suspended. So this length is also given 20 centimeter, and this particle is also remaining at a distance of 10 centimeter always. It is given. Then the charge on the particle they are asking. Let the charge on the particle is Q. Then the forces acting are 1 mg, 1 QE, and 1 tension in the string. Now they are asking the Q. So you can write the equation. It is in equilibrium. Say this angle is theta. Then T cos theta is equal to mg and T sin theta is equal to QE. So you will get tan theta is equal to QE by mg. Now Q given, Q we have to find, E given 2 into 10 power 4, M given 2 gram 2 into 10 power minus 3, G given 10 value, right? Now tan theta will be, this is 20, this is 10. So we have sin theta is equal to 10 by 20, 1 by 2. So theta is equal to 30 degree. So tan 30 is equal to 1 upon root 3. So Q is equal to 2 cancel and 10 power minus 3 minus 6. So Q comes out to be 1 upon root 3 into 10 power minus 6. That is 1 upon root 3 microcoulomb. So the value of X comes out to be 3. Now you see there's nothing very much similar to this question. Now only thing difference is here they have said some plate is there which has been creating the electric field in the neighboring region. Let's take this is also the previous year JEE main question, 6th one. This 7th one is also previous year JEE main question. An inclined plane is there forming an angle of 30 degree with the horizontal is placed in a uniform electric field. This inclined plane is placed in uniform electric field. Electric field value also given. One body is there whose mass, whose charge is mentioned. This body is mentioned. Now, it is allowed to slide down from a height of 1 meter. This height is given as 1 meter. This height from where it is allowed to slide. Find the time taken by the body to reach the bottom. We have to find in how much time it will reach here. In how much time it is going to reach the bottom. Now, what is going to happen? Here the acceleration you can write. Now, mg sin theta, QE cos theta. So the acceleration in this direction, I am writing again mg sin theta, where theta is equal to 30. This is QE. So this is QE cos theta. So the net force in the down the incline will become, net force down the incline become mass into acceleration equal to mg sin theta minus QE cos theta. Theta is equal to 30 degree. So the acceleration down the incline comes g sin theta minus QE by m into cos theta. Now they are asking the distance traveled. So here if this is 1 meter, this is 30, then what will be this distance? Perpendicular upon hypotenuse equal to sine 30. So sine 30 is equal to 1 upon L. L is equal to 2 meter. So this L length of the incline comes 2 meter. So they are asking the time taken by the particle to move the block from here to here. So to move the particle from here to here, we have this acceleration and this length. Time we have to find. So we can say L is equal to 2 meter equal to ut is 0 half a. A is g sin theta. So 10 sin 30 is 1 by 2 minus q. Q given is q. What is the value of q? charge 5 millicoulomb. So 5 into 10 power minus 3, and this E is given as 200, mass is given as 1 kg, QE by m, and cos theta is given as root 3 by 2 into t square. It will come, right? Now 10 into 1 by 2, 5, 5 2 are 10, 1000 is all gone, root 3 by 2. So 5 minus root 3 by 2 into t square, half is equal to 2. So from here you will get the time t as 2 2 are 4 upon 5 minus root 3 by 2. 5 2 are 10, so 8 upon 10 minus root 3. We can solve this. It will come something very close to 1.3 second. Okay, if you want to do the actual calculation, 10 plus root 3, 10 plus root 3, so it will become 100 minus 3, it becomes 97, so it becomes 8 into 11.73 upon 97. Approximately it will come as 1.3 second. Right? This way you can do this question. Now this question is also previous year JEE Main, and I say here the concept of kinematics, NLM and electrostatics has been involved. So there are few multi-conceptual questions in the last 4-5 years. This is among one of them. Now let's take the next question. A positive charge particle of mass 10 milligram, 100 milligram is thrown in opposite direction to a uniform electric field. Say electric field is in this direction and its value is 10 power 5 Newton per coulomb. Now charge particle is thrown opposite to it. Mass of the charge particle given 100 gram. If the charge on the particle is given 40 microcoulomb and the initial velocity is 200 meter per second, then how much distance it will travel before coming to rest? Means finally it has to come to rest. Here very intelligently we can make use of the work energy theorem. They are asking this distance only, what it will cover. Let us say particle cover a distance of s before stopping. Then apply the work energy theorem. Final kinetic energy minus initial kinetic energy mv naught square by 2 equal to, now only force is electric force, work done by the electric force. Electric force is acting in this direction QE, but displacement this way, opposite. So the work done by the electric force is minus QE into S. S we have to find. Minus minus sign cancelled. Mass is given as some 100 milligram. 100 milligram means 100 into 10 power minus 6. V naught is given as 200. So 4 into 10 power 4 by 2 equal to Q. Q is 40 into 10 power minus 6. And E is given as 10 power 5 into S. This cancel. This cancel. This remain 2. This 2. So S is equal to 0.5 meter. Now you see in the last 3-4 questions, they all were multi-conceptual. This question also, 8th one also, previous year JEE Main. Now take this 9th one. This is slightly different type. It is not of previous year JEE Main also. Rod AB is there of mass m and length L, and which is positively charged. So let us make a rod AB of mass m, length L, and positively charged uniform linear charge density lambda. It is pivoted at point A and is hanging freely. Means in this way it is hanging freely. If a horizontal electric field is switched on in the region, electric field is switched on. Find the angular acceleration of the rod. Okay. Now here the concept of rotational motion and the concept of electrostatics has been used. Now you see here rod is having the charge. So when the rod is having the charge, every part of it experience some electric force. So this part will experience the force in this direction. This part will experience the force in this direction. Because of this, a torque will be produced about this point, and because of this torque, the rod will experience some angular acceleration. So let us say angular acceleration is alpha. Now to find the torque, we have to go for the integration technique because here the force is distributed. So at a distance of x here, we are considering a small element of width dx. This is what I have shaded, this particular portion. Now, charge of this portion is equal to lambda dx. Now, the force experienced by this will be dq into E in the shown direction. This force will cause the torque about the point A will be dqe into x. dq is equal to lambda x e dx. So this is the torque. This is the torque about point A only due to the force experienced by this small part, shaded part. Now, if we want to find the total torque, we have to go for the integration. Total torque will be I alpha, or first we have to integrate it, d tau. This is lambda x e dx. X varies from 0 to L. So it becomes lambda e L square by 2. And from the concept of the rotational mechanics, tau equal to I alpha, this is equal to m L square by 3. M is the mass of the rod, L is the length, and moment of inertia ml square by 3 about the axis passing through and into angular acceleration alpha. L square cancel. So alpha you got 3 lambda e upon 2m. This you got the angular acceleration. This option B. Hi students. Here is the practice part of electric field part 2 under fast track revision series for JEE Main. In this part we are going to see the concepts, the problems related to the electric field due to discrete point charges, the point charges, single point charge or multiple point charges. Now here the first question. 2 point charges plus 8q and minus 8q are located at x equal to 0 and x equal to L. This is origin, x equal to 0 and this is x equal to L. Here the particle 8q is kept and here the particle minus 2q is kept. We have to find the location of a point on this line only, x-axis only, at which the net electric field due to these 2 point charges is going to be 0. On this x-axis, we have to identify one point, mark one point, so that where the electric field is going to be 0. Let us say this point is P and its coordinate is x, then it means this entire distance will become x and this is equal to L. Now you may think why I have taken it beyond minus 2k, because when the two oppositely charges are there, the electric field will be 0 outside the line joining them, outside the region containing them, and it will be towards the smaller charge. So at the point P, we are going to see what is going to happen. Now, due to 8q, the electric field is in this direction. Due to 8q, the field is in this direction, say E1. E1 is the electric field at point P due to 8q. So E1 is equal to 1 upon 4 pi epsilon naught k q upon x square. And let E2 is the electric field at point P due to minus 2q. E1 and E2 will be opposite to each other because they are opposite nature charges. E2 will be 1 upon 4 pi epsilon naught q upon distance, that is x minus L whole square. Net resultant field at point P is E1 minus E2, which they are saying has to be 0. So we can say E1 is equal to E2. After substituting it, we'll get k into 8q upon x square equal to k into 2q upon x minus L whole square. K cancel, 2q cancel, 4 left. So we are left with 2 times of x minus L is equal to x. So you will get 2x is equal to 2x minus x equal to 12. So x equal to 12. This is your answer. Now only the superposition principle, electric field at any point due to many charges is equal to the vector sum of the electric field due to individual charges. Now take the next question. A point charge of 10 microcoulomb is placed at the origin. Point charge of 10 microcoulomb is placed at the origin. This is the origin. At what location on the x-axis should a point charge of 40 microcoulomb be placed? Let us say at a distance x, 40 microcoulomb we place so that the net electric field is 0 at x equal to 2. Means at 2 centimeter. This total is x centimeter. Say this OP is 2 centimeter. OP is 2 centimeter. Here the net electric field 0. Now since here both the charges 10 microcoulomb, 40 microcoulomb are of same nature, field will be 0 in between them. If this is 2 centimeter, this will be x minus 2 centimeter. Here I am taking x in centimeter only. Now the field at this point, field at point P due to 10 microcoulomb will be in this direction E1 and due to 40 microcoulomb will be in the leftward direction E2. E1 is the electric field at point P due to 10 microcoulomb. So K into 10 microcoulomb upon R square, that is 2 square. Here I am not converting the charge in coulomb and distance in meter. I am leaving it in, or to be more on the safer side, millicoulomb and centimeter square. And E2 will be equal to the field at point P due to 40 microcoulomb charge. So 40 microcoulomb upon 2 minus x centimeter square. Now net electric field has to be 0. So E1 minus E2 has to be 0. So we'll substitute E1 equal to E2. So K into 10 upon 2 square microcoulomb per centimeter square is there, is equal to K into 40 upon 2 minus x whole square microcoulomb upon centimeter square. The value of K, unit of K, I have not written in this expression. This cancelled and we are going to have this 10 will be cancelled here and it will become 4. So 2 minus x is equal to 2 into 2. So x is equal to 2 minus x whole square equal to 4 into 2 square 16. So 2 minus x equal to 4. So x equal to minus 2. How minus 2 coming? Oh, sorry, I have written here 2 minus x. It was not 2 minus x. It will be x minus 2. It is x minus 2 whole square, x minus 2 whole square, x minus 2 whole square. So x is equal to 4 plus 2, 6 centimeter. So your answer will be this one, right? Again, it is very much similar to the previous question. Both were previous year JEE main question. Now this is not previous year JEE main question, but again here some other things will come. Now they are saying 2-point charges 2 microcoulomb minus 2 microcoulomb. This is 2 microcoulomb, this is minus 2 microcoulomb are placed at points A and B whose coordinates are given. Find out the electric field intensity at point C and D. We have to find the field intensity at C and D. Now we are finding the field intensity first at B only, C only. Now due to A, electric field here will be E1 and due to B, electric field be E2. You have to remember electric field due to positive charge is away and away from the charge. Due to negative charge, it is towards the charge. So let's find the value of E1 and E2. We are doing at point C. E1 is equal to K Q upon this distance. This distance is how much? Root 2 and 2 root 2. That is 3 root 2 whole square. And E2 is K into 2 upon 2 root 2 minus root 2. That is root 2 whole square. And the net electric field at point C is equal to E1 plus E2, which comes out to be K into 2 upon root 2 square is common. So 1 upon 9 plus 1, it comes out to be 9 into 10 power 9, 2 into 10 power minus 6, root 2 meter or centimeter it is given. All the distances are in meter. Root 2 square 2 into 10 by 9. 9 9 gone, 2 2 gone. It will come out to be 10 to the power 3 and 4. 4 Newton per coulomb. Electric field at point C. Now find the electric field at point D. Electric field at point D due to this charge will be this direction and due to this charge will be in this direction. And both are going to have the same magnitude, say E. Say this angle is root 2, this is also root 2, so this is 45. So this component cancel and net electric field will be in this direction along the negative x-axis. So we can say the net electric field at point D is equal to 2E sine 45, that is 1 by root 2, that is root 2E, and the value of E will be 1 upon 4 pi epsilon naught K Q 2 microcoulomb. Q I am writing upon root 2 square plus root 2 square. So 2 square plus 2 plus 2 4. So it will become 2 square. So your expression will be root 2 into 9 into 10 power 9 into 2 into 10 power minus 6 upon 2. 2 cancel, it becomes 9 root 2 into 10 power 3 Newton per coulomb. This is the electric field at point D. Now let's take the next question. In this question, it is mentioned there are 4 point charges minus Q, Q, plus Q, and minus Q are placed on the y-axis at y equal to minus 2D, minus D, plus D, and plus 2D. Now we have to find the electric field due to these 4 charges, resultant electric field at point P, which is on the x-axis at a distance of capital D from the origin. Means OP is equal to D given, and it is also mentioned that D is much greater than capital D. And it is also mentioned that we don't have to find the entire expression of the electric field, but we have to find only that how the electric field at point P varies with capital D. Means not the complete expression, but only the behavior with capital D. So let's see. Due to these two positive charges, the electric field here at point P will be, say, E1, because they are same charges. That's why marked like this. And at this point, due to minus Q charges, this is due to these two minus Q charges, electric field is E2. Now it is, let us set this angle theta 1 and some angles are shown theta 2. Now the component of E2 along the y-axis, these two, this will be cancelled. Same way component of the E1 also will be cancelled. It means the net electric field will be only along the x-axis, and that will be equal to the E is equal to net resultant field will be two E1 cos theta 1 minus 2E2 cos theta 2. This will be our final answer. Now let's find the value of E1, E2, theta 1, theta 2, and we'll be able to solve. E1 is equal to 1 upon 4 pi epsilon naught Q upon this distance from here, say this is x to p distance, which is equal to capital D square plus small d square. So capital D square plus small d square, and E2 will be equal to kq upon capital D square plus 2d whole square, that is 4d square. And cos theta 1 value will be written as, cos theta 1 is base upon hypotenuse, that is capital D divided by under root capital D square plus small d square. Same way cos theta 2 is equal to capital D upon capital D square plus 4 small d square. Substitute these things in that above expression. We are going to have the total E as KQ is common, so I have taken it out. 2 is also common, so taken it out. E1 cos theta 1. So KQ, 2KQ outside. So D upon under root D square plus D square whole cube minus D upon under root D square plus 4D square whole cube. This will come. Right? Now we have to simplify this term in expression. Now this term in expression, what you do, 2KQ in the denominator, take capital D outside. So it will become D square common outside. So D cube 1 plus d square by capital D square 3 by 2 d here minus d upon d cube 1 plus 4d square upon d square 3 by 2. So we can take this as this can be written as 2k cube upon d square 1 plus d square upon capital D square to the power 3 by 2 minus 3 by 2 1 plus 4d square upon capital D square to the power minus 3 by 2. Now this we can write as 1 minus 3 by 2 d square upon d square plus higher powers plus higher powers. This is the first term and first bracket, and second bracket is 1 minus 4 into 3 by 2 d square upon d square plus higher powers. This I have written only this bracket term here. 1 minus 1 cancelled. Now this minus 3 by 2 3d square upon 2d square, and here plus 4 into 3 by 2 d square upon d square plus higher powers. This all higher powers negligible, ignored. So what we left? It is 2k cube upon d square into, now this will be 3 into 3 by 2, that is 9 by 2 into d square by d square. So it will become, electric field will become proportional to 1 upon t to the power 4. So see which option is matching. Option 3 will match. It is a nice question, lengthy question, previous year JEE main. So you, lengthy means calculation you have to do. Okay. So even if you know the concept and you are not able to solve the things, then anyway you are going to get no marks. So it is also very much important that you are able to do the things mathematically well. Now let's take the next question. Two charges are mentioned, Q2 and Q minus Q3, and in the question it is given, if the net electric field at this point P along the y-axis, in this direction the field is 0, then you have to find the ratio of the magnitude of the charges Q2 and Q3. So in the question as such it is not mentioned that this point is the P is on the y-axis, but we are going to assume that this direction is the y-axis. So here what we are going to do, electric field at point P due to Q2 will be in this direction, say E1, and electric field due to Q3 will be in this direction, say it is E2. Then the value of E1 and E2 are, E1 is K Q2 upon this distance. This distance is 2 square plus 4 square, that is root 20. So in centimeter only I am writing root 20 whole square. And E2 is equal to K, this is E2, KQ3 divided by 3 square plus 4 square under root, that is 5 square. Now they are saying the component of the electric field along the y-axis is 0. Let us take this angle is theta 1 this angle is theta 2, then we are having this angle theta 1, this angle theta 2, this component, y component is 0. So the net electric field along the y-axis is E1 sine theta 1 minus E2 sine theta 2. And this is given as 0. It means E1 sine theta 1 is equal to E2 sine theta 2. Now the task left to find the value of theta 1 and theta 2. Let's see in this particular triangle. In this triangle, sine theta 1 will come out to be E1, also I am writing k q2 upon root 20 whole square. Sine theta 1 is 4 upon root 20 is equal to E2 kq3 upon 5 square into sine theta 2 is 4 upon 5. This is 4 and this is 5 and this is 4. So sine theta 2 is 4 upon 5. Now we have equated k cancel, 4 cancel, and we have to find the mod of q2 by q3. So mod of q2 by q3 is equal to root 20 cube divided by root 25 cube. So it will become 8 upon 5, 5 cancel, 5 root 5. So it is given, this particular thing is given as 8 upon 5 root x. This is mentioned as 8 upon 5 root x and we have to find the value of x. So x comes out to be 5. This is your answer in this. This is previous year JEE main question. Right? Come to the next question. In this question it is given 3 charged particles ABC. 3 charged particles ABC are there with charges minus 4q. A is having minus 4q, B minus 2q and C minus q. A minus 4q, C and B. Present on the circumference of a circle of radius d. Here radius is given as d. Charged particles A, C and center of the circle form an equilateral triangle. A, C and this is an equilateral triangle. Means this angle is 60, this angle is 60. So 30, 30 already mentioned. And this distance between the A and C is also equal to the radius. You have to find the electric field at point O along the x direction. At this point, you have to find the electric field along this direction. This is what you have to find. Now let's try this question. Now at center, electric field will be due to 4 charges. Sorry, due to 3 charges. Due to A, negative charge, due to A, electric field will be in this direction, E1. Right? And the E1 value will be K Q upon D square. Now, electric field due to B at this point is in this direction, E2. And due to C also in the same direction, E3. Since both the charges are having equal magnitude, distance of the charge from A is same distance. So the value of E2 and E3, E2, E3 both will come in the same direction. So the value of E2 and E3 are equal to K 2Q upon D square. Now, if you see E1 in this direction, E2, E3 in this direction. So the net resultant electric field we can say E1 in this direction and E2 and E3 in this direction. So this is same. So E2 plus E3. Now, if you add E2 and E3, you are going to get K into 4Q upon D square, which is same as the E1. It means in this direction also K into 4Q upon D square and in this direction also. And these two vectors are at an angle of 60 degree. So when two vectors of equal magnitude are at an angle of 60 degree, their resultant will be in this direction, and you can find either by using the vector sum. So the E resultant is equal to under root E1 square plus E2 square plus 2 E1 E2. Here it is, I am saying E2 naught. This is equal to E2 naught cos 60. Cos 60 is 1 by 2. So this cancel and both are equal E1 and E2 naught. So it will come out to be root 3 E1. That is root 3 into K 1 upon 4 pi epsilon naught into 4Q upon D square. 4 cancel. So you have root 3 Q upon pi epsilon naught D square. This is the answer. First option. So if you see, it is also previous year JEE main question. Question is very easy. Calculation is also very easy. But if you become hodgepodge in solving this question, then unnecessarily you will lose the marks. I will suggest in these type of question, be little, maintain the patience. Okay, let's move to the next question. Okay, let's move to the next question. Let's take the next question. Three charges plus Q, 2Q and 4Q are connected by two strings AB and BC as shown in figure. And they are saying find out the ratio of the tension in the two strings. These three charges are connected to the two strings, like three charges, and these two are the strings. And they are asking the ratio of the tension in the two strings. So let us say tension in the two strings is T1 and T2. So we have to find the ratio of T1 and T2. So if I see the charge A and charge C, now charge A experiences one force due to B and one force it experiences due to C. I marked F1 and F2. F1 is equal to K Q into 2Q upon D square and F2 is equal to K Q into 2Q, Q into 4Q upon 2D whole square, that is 4D square. And it experiences another force by the string AB, that is T1. While the C experiences the force, one is the tension in the string, one is the force by A, which is nothing but equal to F2, and one is the force by B, say F3. And F3 will be equal to the force between this and this charge, electric force between these two charges. So it will be equal to K 2Q into 4Q upon D square. Since both the charges are in equilibrium, all the three charges are in equilibrium. So A is in equilibrium. So T1 is equal to F1 plus F2. If we substitute these values, then we'll get, I am writing KQ square upon D square is common only in both the term. So it left only 2, and here it becomes 4 upon 4 cancelled, it will become 1. So it will become 3KQ square upon D square. And F2 is, T2 is equal to F2 plus F3, that is KQ square upon D square is common. This is F2 factor left and F3 is 8. So it is 9KQ square upon D square. So the ratio T1 by T2 comes 3 by 9, that is 1 by 3. So your answer will be B option, right? Let's take the next question. 4-point charges are held at the vertices of a square of side A. Find the magnitude of electric field at the center. Now they are saying 4 charges are there. Q, 2Q, 3Q, 4Q. And at center we have to find the electric field. Now in this, if we see, due to Q, the field is in this direction E1, and E1 is equal to KQ upon, I am taking this distance, center to vertex distance, as say x. Later on we'll write its value, KQ upon x square. And due to 3Q, it will be E2 in this direction, and E2 will be 3KQ upon x square. Due to 2Q, it is E3 due to this charge. So E3 is K into 2Q upon x square. And due to 4Q charge at the center, field is say E4. Then E4 is equal to K into 4Q upon x square. Now you have to see this E1 and E2 are opposite to each other. E3 and E4 are opposite to each other. So we can do the vector sum of E1, E2 and E3, E4 separately. KQ upon x square, E1, E2, 3KQ upon x square. So it means the net field due to E1 and E2 will come in this direction, equal to only KQ by 2KQ by x square. So here I am writing 2KQ by x square, resultant of E1 and E2. And E3, E4 also opposite to each other, and the resultant is going to be along the E4 direction. So due to E4 and E3, resultant in this direction equal to 2KQ upon x square. And x is equal to, this total distance is root 2a. So root 2a by 2, a by root 2. X is this. So now these are two vectors of equal magnitude at an angle of 90 degree. So their resultant will be in this direction. So the resultant of these two vectors will come out to be in this direction. And this is going to be equal to, resultant electric field will come out to be root 2 KQ upon x square into 2. And x is equal to a by root 2. So 2 root 2 KQ upon x square. X is a square by 2 it will become. So your answer will become 4 root 2 q upon 4 by epsilon naught a square, that is root 2 q upon by epsilon naught a square, and direction is this one, right? It is also the previous year JEE main question. Now come to the next one. Three identical charges are located symmetrically along a circle of radius r. Three identical charges are located symmetrically. Symmetrically means they will be located at the vertices of an equilateral triangle. Resultant electric field at the center of the circle. At this point, at the center of the circle, what is going to be the electric field? We have to find it out at this point. And these all are same charges, Q, Q, Q. Right? Q. Now, electric field due to all the charges will have the equal magnitude here. Due to this charge in this direction, due to this charge in this direction, and due to this charge in this direction. So E1, E2, E3. And what is the special thing about E1, E2, E3? They are equal in magnitude. In magnitude, these three are equal, but they are spreaded at an angle of 120 degree. But in the space, they are spreaded at an angle of 120 degree. So it means it becomes three vectors of equal magnitude are spreaded in space at equal angles symmetrically. So we know the fact that any number of vectors, if they are spreaded symmetrically in the space, their resultant will be 0. So here the answer directly without solving you can say is 0. C. Sorry, option A. Next, move to the next question. Now in this question, they all are almost similar. This is also previous year JEE main question. Three charges q by 2, q and q by 2 are placed at the corners ABC of the square. At these three corners, these three charges are there. Right? And side of the square is given as A. The magnitude of electric field at the corner D of the square. At the corner D. Here I think there is a small mistake. This must be D and this must be C. So at this point we have to find the electric field. So let's find that. Now due to A, electric field is in this direction E1 and value of E1 is k q by 2 upon A square. So let us keep 1 upon 2 kq upon A square. So this factor I am writing as some constant, say alpha. So alpha by 2. Due to charge at C, again same value. Here comes E1 only alpha by 2. And due to B, it comes in this direction, say E2. And E2 is equal to k q upon A square 2A square. That is 1 upon 2 kq upon A square. That is again alpha by 2. So E2 is alpha by 2. So now the question reduces that we have to find the vector sum of three vectors. This is alpha by 2, this is alpha by 2, and this also alpha by 2. Resultant of these two, E1 is alpha by 2 root 2, and 1 alpha by 2 root is already there. So your answer will become alpha by 2 root 2 plus 1. And alpha we have written as kq upon A square. So kq upon 2A square into root 2 plus 1. So k is 4 pi epsilon naught A square. So 1 upon 2 plus 1 upon root 2. This option will come. I'll write once again q upon 4 pi epsilon naught A square and 2 taken inside 1 by 2 plus root 2 by 2, that is 1 by root 2. So yes, these two options are same. So answer will be C. Sorry, first option. Now this you take. This question is also previous year JEE main. Now two charges are there Q1, Q2 at points A and B. Q1, Q2 at points A and B of right angle triangle OAB. Resultant electric field at this point is perpendicular to the hypotenuse, means it is in this direction. It is the perpendicular. Then you have to find the ratio of Q1 to Q2. Now I would like to solve this question. If I take vector form, it will be easier. Now, electric field due to Q1 here is this direction, k Q1 upon x1 square. And due to Q2 is in this direction, k Q2 upon x2 square. And this electric field has to be perpendicular to this line. Means it has to be in this direction. It means this electric field component is 0. This component of the electric field is 0. So we can write, say this angle is alpha. Let's make a separate diagram. This angle is alpha. This angle will be 90 minus alpha. Then this direction is k q2 upon x2 square. Cos alpha component this side it will come sin alpha component, sin alpha minus k q1 upon x1 square into cos 90 minus alpha cos alpha is equal to 0. If you are able to find this, then you will get the required ratio. Now this angle is alpha, this angle. So this angle is also alpha. If this is alpha, this is 90 minus alpha. This is 90 minus alpha means this is alpha. If this is alpha, then Q2, what we have to find? The ratio of Q1 to Q2. Then I can equate it to this, K cancel. So Q1 by Q2 is equal to, Q1 by Q2 is equal to x1 square upon x2 square into sin alpha by cos alpha, that is tan alpha. X1 square upon x2 square tan alpha. Tan alpha is equal to perpendicular upon base, that is x2 by x1. So answer comes x1 by x2. This is the answer.